Okay, so this is probably a little bit of a different video series about divisibility, and I'm more or less just doing this one for fun. So there might be quite a few things in here that might be very confusing, but hopefully it'll be a little bit less confusing than when we started. So what I want to do is look at this idea of divisibility by 3. It works for 9 as well, but we're going to focus on that it works for 3, and then we'll see hopefully by the end of this series why it would also work for 9. Okay, so first of all, what is divisibility? I mean, I think we use this word, but I think it's important that we don't confuse it with the word multiple. Divisibility, multiple, they're different words. So the idea is that if I take something like 21 and I divide it by 3, notice that what I get here is an integer. Okay, that's the key. So when I say integer, I mean a whole number. So we can say that 21 is divisible by 3. Okay, or basically I could say that 3 divides 21. There's a number of different ways we can say this, but 21 is divisible by 3. Whereas if I try to do the same thing with 5, we get 4.2. So because that's not an integer, we would say that 21 is not divisible by 5. So the theorem of how this works with 3 and 9 is that it's going to be divisible by 3. So any integer, any whole number is divisible by 3 or 9, if and only if the sum of its digits is divisible by 3. So I think, again, this can potentially be confusing, but just to clear it up, let's do a couple examples. So if I take a big number and I divide it by 3, so 24,723, and I divide it by 3, I actually get a whole number out of this. So I would be able to say that this 24,723 is divisible by 3. That's what I would be able to say. However, easy way to check that this is true, suppose you didn't have a calculator, is I could simply add up all of the digits, and then whatever my result is, in this case 18, notice that this is also divisible by 3. Okay, so the key understanding here is that both the 24,723 and 18, which is the sum of its digits, both of those numbers are going to be divisible by 3. Okay, but it also works the other way. So if I take something that is not divisible by 3, so let's say I take 32,578, and I try to divide that by 3, I'm going to get this crazy number here. It has a repeating decimal, so it's not an integer. But if I take the sum of those digits, you'll notice that 25 is also not divisible by 3. So the key here is that you're always going to have a situation where a number and the sum of its digits will either both be divisible by 3 or they both won't be divisible by 3. Okay, so this is a great divisibility check if you want to see if a large number is divisible by 3 or not. Simply add up all the digits and check to see if this much smaller number is divisible by 3. And hopefully we know that 18 is divisible by 3 if we know our 3 times tables. But that way I don't have to check in my head whether or not that's divisible by 3. I just have this nice trick. One little thing I do notice here is that these both have a repeating decimal of 3, and we're going to see later that that's actually not coincidence. Um, so, um, I guess the natural question that I want to ask in this series is, does this work for every integer? I did an example. And then if so supposing that this is true, why does it work? What is the underlying math that allows it to work? And that's really what mathematicians are interested in. They're interested in why these things work. But to do that, we need some kind of proof, okay? It's important to understand that it's not like I can just choose a whole bunch of numbers and look for a pattern and see if it's true. Don't get me wrong, that's not a bad way to conjecture and to come with a reasonable idea of why this might be true. But we need to actually come up with a more generalized proof, and we're going to go through that. And then this will also help us understand why that this is true. Okay, and that's really at the core behind a proof. It's not. I feel like sometimes we get this idea that it's to basically show your teacher that you know what you're talking about. But I don't think that that's the case. I think proofs are more essential for helping you as the learner to understand why some mathematical fact is true and not just take it as a given. You see, I think that's the wonderful thing about math is that um, it's not like you just need to take my word for it. I can tell you that this is a true statement. You can believe me that it's true. But I could be lying to you, okay? But the nice thing about math is that we don't have to worry about that because all of this stuff is verifiable. There's a way in which we can prove it. And while you might not understand all the steps of the proof, the goal here is just to understand this can be proven and maybe to learn a little bit more of why it works, even if we don't understand all the steps. So this is going to be the end of our first part, and then we'll just keep going. So take care, guys, and I'll see you guys in the next video.